This will be the last lesson for this section, and here we'll learn how to convert data structures from one form to another. We'll use objects we created in the last lesson, specifically a slightly modified version of our list object, myList. This myList is now without the function typeOf. That's because typeOf isn't actually a data structure, it's an object on its own. We only use it to illustrate that list can store any type of object, including functions. You can convert between data structures using as dot followed by the desired data structure type. For example, as.vector to convert to a vector, as.matrix for a matrix, as.list for a list, and so on. Let's start by taking our matrix object and we'll convert that to a vector. First, we'll print my matrix, then we'll run this code. As you can see, it's printed as a single vector. If you use is.vector to confirm if this is truly a vector, you will see the response is true. I'll assign this to a variable called my mathvec, just to show that we converted this from a matrix to a vector. So is.vector, my mathvec, and yes, it's true, it's a vector. Converting from a matrix to a data frame is also quite easy. We'll use as.data.frame and pass in our matrix object, my math. This is actually a very common operation in R. One thing to note about converting from a matrix to a data frame is that a name will be assigned if one isn't already provided in your matrix object. When converting from a data frame to vector, care needs to be taken, because if you convert it directly, you might get a strange result. So we can try as.vector and pass in the dt object. When we pass in dt into as.vector, you'll see we have this too. And you might wonder if this is a vector. It is actually, only that it is a named vector. If we move ahead and unlist the vector, you will see that each element of the vector will be given a name. And you generally don't want something like this. But who's to say, the knowledge might come in useful. If you really want vectors from a data frame, simply access the column you're interested using the $sign. If you use the square bracket, you get a data frame returned. For example, $sign cohex. Then you pass it into as.vector, but we don't need as.vector in this case, because accessing a single column in a data frame with the $sign already returns a vector. We've seen that before, but let's see it again to further stamp it in our memory. So copy and paste this and we have 1 to 10 as the result again. Care must be taken when converting from a data frame to a vector. It's best to convert a single column rather than trying to convert everything at once. Well, if you must convert the entire data frame to a vector, there's an argument within the onList function we can utilize. Firstly, you unlist the data frame, in this case dt, then if you press tab, we will see use.names argument, and we pass in false as the value, and we get the following result. This is another way to convert data frames to vectors, but I see no use for it at this stage. Of course, we can confirm if this is also a vector. So we nest all this into is.vector, and the result is true. Next is converting from vectors to data frames. We have used vectors in data frames multiple times. I'm sure there will be no difference if we use as.data.frame for this. We have as.data.frame, then we have x, or let's use y. And it's not a surprising result. It also takes the variable name as the name of the column. Next up is lists. With lists, you have to tread with care. And that's because it holds objects, and not just objects that are data structures. Let's try converting the myList object to a data frame. We have as.data.frame, then we pass in the object myList. Look at this. It says error. Error in as.data.frame cannot coerce class function to a data frame. That means there's a function class there. So we can check this by printing out myList first. And yes, indeed, there's a function. This is it. And it seems I'm yet to reassign myList. So I will reassign myList here. And if we check myList now, we no longer have a function. So let's try this again and see what you get. And look at this. It's not really clear for a data. It's generally better to unlist or extract objects if you want to convert them. But there's still a lot to learn from this situation. Let's break the results down and look at this. My list 1. The first object of my list is simply 1, 2, 3, and that's what you have here, 1 to 10. The second object is the alphabet. That's A, B, C, okay? But the interesting thing is, if you look at this, x1 to 10, that is the name of this column. If you look at the next one, that is the name of the next column, and this is not understandable for a column name. Let's confirm the name by nesting all these in names function. We can confirm this is a name, x1.10. Then we have this column, A to J. It's an ugly name. But we see that the object is still here, A to J. This is our second object. Then we have 1 to 5 appearing twice. And we have 6 to 10 appearing twice. This should tell us that this is the matrix object. So what happened here is the matrix object, which is something like this, 1 to 10, was repeated twice. And that's because in data frames, the rows need to be equal for every column. You should also notice what's happening here. It's not only our matrix that is being recycled, but we also have my obj, which is just a character recycled to fill in all the rows. And we have dt printed nicely here without issues. And that's because it has the dimensions 2 by 10, 10 rows and 2 columns. And at last, my obj is repeated multiple times, as said earlier. There is also as.list, and this is quite easy to work with, and that's because it can accept anything. As.list, pass my math, it goes in there, breaks it down, and converts each of its observations to a list. And you won't do this in practice, but it's just to show you. And this is also the same for vectors. Now for data frame, if you try converting data frames to lists, it gets broken down according to the variables it's having. And that's because data frames are collections of atomic vectors. So it breaks it to individual atomic vectors, which are the variables in this case. In general, converting from one data structure to the other is quite straightforward, but you should always check the underlying structure before you convert from one form to another. So you might need extra manipulation in some cases. For example, if you want to convert a list to a vector. Yeah, aside from that, it's quite pretty direct. Oh, also, when converting matrix to data frame and from data frame to matrix, just know that when you are converting from a data frame to a matrix, the object type will be converted to a single type. A matrix can only hold a single data type. I think you should keep that in mind. So this brings us to the end of this section, and I would have to commend you for sticking with me up to this point. Learning a new language, it's not easy, but you've done great. If you are here, you've done really great. What I would like you to do now is you take a rest, you chill, you watch your favorite show, an anime or something, anything that you do just to relax. Then after you feel rested and refreshed, you can pick up on the next session where we'll be discussing control structures.